Are you finding Solvay process difficult to explain and even understand? In this video, I will explain the Solvay process step by step, breaking down every step with a befitting chemical equation for your understanding. So stay tuned as I explain Solvay process the Chemist AI way. I am going to start with definition. Solvay process is simply the industrial manufacture of sodium trioxocarbonate 4 or sodium carbonate from ammonia, sodium chloride, and calcium trioxocarbonate 4 to give sodium trioxocarbonate 4. But this process is a bit complex. It is not just direct combination. There are steps that lead to production of sodium carbonate. Step 1 is the preparation of ammoniated brine. Brine simply means sodium chloride, that is table salt, dissolved in water. So brine is NaCl plus H2O. Then ammoniated means adding ammonia gas to brine. Ammoniated brine is brine plus ammonia. And when ammonia is added to brine, ammonia is only interested in water and not sodium chloride. So ammonia reacts with water to give ammonium hydroxide. And sodium chloride will just hang around in the solution. Now we get to the next step, step 2. Step 2 is production of carbon 4 oxide and quicklime, that is calcium oxide, by heating limestone, calcium trioxocarbonate 4. So when limestone is heated, it produces two important raw materials for the Solvay process, which are calcium oxide and carbon 4 oxide. And I think it is very important to note the functions of calcium oxide and carbon 4 oxide respectively. Carbon 4 oxide is used for the carbonation of the ammoniated brine. The product formed during the ammoniation of brine is reacted with carbon 4 oxide for carbonation, while calcium oxide is used for the recovery of ammonia, because ammonia is an important raw material. It has to be recovered for another Solvay process. Now, we move to step 3. Carbonation of ammoniated brine forms step 3. Remember, in step 1, we prepared ammoniated brine. Step 2, we prepared calcium oxide and carbon 4 oxide. In step 3, we are going to react carbon 4 oxide with the ammoniated brine. And when we talk about ammoniated brine, we are simply talking about ammonium hydroxide, which was formed through ammoniation of the salt solution. So carbonation in this sense is reaction of ammonium hydroxide with carbon 4 oxide. So we write CO2 plus NH4OH. Carbon 4 oxide is acidic oxide. Ammonium hydroxide is a base. So this is a sort of acid-base reaction. So we are going to produce salt and water. So because carbon 4 oxide is involved, we are supposed to have salt, water, and carbon 4 oxide. But this salt, water, and carbon 4 oxide are integrated into a single molecule, ammonium hydrogen trioxocarbonate 4. Everything is there. Ammonium, which contains H plus, part of water. Then hydrogen trioxocarbonate 4, which contains the OH part of water, and carbon 4 oxide. So ammonium hydrogen trioxocarbonate 4 is just salt, water, and carbon 4 oxide integrated as a single molecule. And importantly, this ammonium hydrogen trioxocarbonate 4 will be reacted with the brine. Remember, this is carbonation of ammoniated brine. We have reacted carbon 4 oxide with ammonium hydroxide. We now react the product, ammonium hydrogen trioxocarbonate 4, with the salt itself in the brine, sodium chloride. And sodium from the sodium chloride will displace ammonium ion in ammonium hydrogen trioxocarbonate 4 to give sodium hydrogen trioxocarbonate 4, and the ammonium ion displaced will attack chloride to form ammonium chloride. Now, it is getting more interesting. Sodium hydrogen trioxocarbonate 4. You can see it resembles sodium trioxocarbonate 4, which is the chief product. So once we get sodium hydrogen trioxocarbonate 4, we perform filtration to filter it out. After filtration, step 4 will now be heating the residue, sodium hydrogen trioxocarbonate 4. Remember, hydrogen trioxocarbonate 4 is just water and carbon 4 oxide. So when we heat sodium hydrogen trioxocarbonate 4, we get rid of water and carbon 4 oxide. to now acquire our final product, sodium triiosocarbonate 4. So sodium hydrogen triiosocarbonate 4 plus heat will give us sodium triiosocarbonate 4. Then water and carbon dioxide will be eradicated from the system. But wait, getting our final product doesn't mean the end of Solvay process. Solvay process must end with recovery of ammonia. So step 5 is recovery of ammonia. To recover the ammonia, the calcium oxide in step 2 is very important. So that calcium oxide must be converted to slaked lime, calcium hydroxide, which will now attack the ammonium chloride in step 3 to recover the ammonia that was used up in step 2. So calcium oxide plus water gives us calcium hydroxide, and this calcium hydroxide will be reacted with ammonium chloride that was gotten in step 3. And what we are going to get, calcium will attack chloride, and we have calcium chloride. We have ammonia gas liberated, and another thing that will be formed is water, because ammonium chloride is acidic and calcium hydroxide is a base. So this is just like acid-base reaction to give salt, water, and ammonia. And when ammonia is finally recovered, it is quickly recycled back to step 1 for another Solvay process. And this is the end of Solvay process. Do you have any question? Drop it at the comment section. Subscribe and switch on the notification bell for more chemistry concepts like this. Do have a wonderful day. Bye.